Hi, I'm Devin Humble. These are my physics corrections. I'm a senior at UTC and exercise science major. So right here we have the uniform beam, 6 meters in length. It weighs approximately 51 kilograms. We have a man standing on this plank 1.5 meters from the left of it, and his weight is 81.6 kilograms. We also have this rope holding it up right here at a tension force, and we have a second rope holding it up on this side 2 meters away from the edge at a second tension force. So we need to find out the forces between, well, the sum of the force, not the sum of the force. We need to find out the force between F2 and F1 respectively. So to find this, we also know that the net torque and the net force are both equal to 0. So we're going to start out by finding the force of F2, the net torque of F2. So net torque is equal to 0, which is the sum of all the forces. Torque of the man, which is right here. Torque of the beam right here, and then the torque of F2 right here. We don't have to find the torque of F1 because I'm going to set that as my pivot point, and pivot point setting it right there makes torque 0 because it has to be force times the radius. If there's no radius, there would be no torque. Alright, so the torque of the man, if it's going to go clockwise, if it's going to swing clockwise, it'll be negative. If it's going to go up and counterclockwise, it's positive. So our F2 will be positive, but our torque of the beam and torque of the man are both going to be negative. So our force for the torque of the man is going to be negative. So it's the 81.6 kilogram times 9.8 meters per second, force of gravity, which equals to negative 799.68. And we're going to have to times that by the distance it is from the pivot point, so 1.5 meters, plus the torque of the beam itself, which weighed 51 kilograms times 9.8 meters per second, which equals to negative 499.8 times the distance again from the pivot point, which was 3, plus F2, which we do not know for F2 just yet, but we do know that it is a force times a radius, and that all is set to equal to 0. So if we do our algebra and move it over, we get, well, if we add, do the math on these first and get the numbers, we end up getting 1199.52 plus negative 1199 plus another negative 1499.4, and then again plus force of 2 times the radius equals 0. Move that over, our problem then becomes, let's see, 1199.52 positive plus 14.99, well, 144.9, get rid of that, 9.4 equals F2 times R, divided by R on both sides. And the radius for F2, we've got it right here. There's a 2 meter distance from this side to this side. The whole thing is 6. So from here to here, we know it's got to be 4. So our radius for F2 is 4. So this is going to give us our force for F2, which will then equal, if you do the 1199.52 plus 1499.4 divided by 4, that gives us 674.73 Newton meters, and that is our force for F2. All right, now that we've got that, we can now solve for the torque, or the force of F1. All right, and so we know that torque and force, they both have to equal up to 0, so F net has to equal up to 0, so F net of the forces has to equal 0, and that's going to be the force of 1, which is right there, plus the force of 2 right there, plus the force of the balance beam, the weight of it, plus the force of the man. All right. And we can make, we're going to set, since the force is going down on the force of the man and the beam, we're going to make those negative, and the force is going up, supporting it on F1 and F2 and the ropes, we're going to make those positive. So if we go down right here, we don't have an F1 yet, so we'll just go ahead and leave that as it is. F2 is going to be what we found right here, the 674.73 Newton meters, plus the FW, which is the force down on the bar, which was our negative 499.8, because that was just the weight of the bar times 9.8 meters per second squared from right here, plus the force of the man, which was our negative 799.68. So all that, plus our F1, all that has to equal to 0. So using this, we can do simple algebra to get it down. So once we combine like terms, we get F1 plus, it's right here, sorry. F1 plus 624, or minus 624.75 equals 0. So we'll add 624.75 to this side. So then our F1 equals 624.75 newtons. All right, just to recap on this part right here, force 1 plus force 2 plus force of the weight of the beam plus the force of the weight of the man. F1 we don't know yet. We have the force of 2, the rope pointed up, which was the positive 674.73. The force of the beam, negative 499.8, plus the force of the man, which was negative 799.68. After combining like terms and then minusing it to get to the opposite side, we end up getting 624.75 newtons for the force of 1, and the force of the F2 we found to be 674.3 newtons. Not Newton meters, I apologize for that. Let's go back. It's not Newton meters, it's just newtons right here. Since we divided it by the 4 meters in the denominator, that took away the denotation of the meters. So 674.3 newtons for our F2 and 624.75 for our F1. All right, thank you.